I've worked with quite a few of the platforms from the Step 7 1200 to the S7 400 series with the 400H high redundancy series. I've worked with some of their VFD drives and their servo platforms as well.
Um, what industries have you worked on? Have you worked in on Siemens projects?
I've worked in medical, automotive, defense, a couple of really awesome projects in all of those. Uh, what's that?
Food?
Food. I have worked in food, yes.
Cool. See, I think you said you wanted to talk about DRS project and a Lockheed project? Right. Without saying the word. Can you talk about DRS in vague terms? Basically, what was interesting or unique or challenging about it?
So the actually both of the defense projects had similar requirements. These are large scale, Navy vessels, and they need survivability. So the units have to operate even if one of the PLCs goes down, whether that's from uh, random failure or battle damage. And the issue is actually making sure that as much of the equipment that still exists continues to run. And beyond that, you just need a level of traceability and reliability that isn't required in a industrial setting where maybe if something fails, it costs money, but not lives.
And then why would somebody choose DMC for Siemens work based on just in general or like specific to the work that you've done on those projects?
We have one of the best teams in the United States, possibly in the world, where we've walked into projects that were ongoing, large scale, with a number of people working on it, and changed direction to a more optimal path, something that solves their problem better, cheaper, more reliably. And we do this on a regular basis, whether it's a project we start up, creating something that really works for our client, or coming in later and helping a client achieve what they wanted to do in the first place.
Cool. And how long have you been working with Siemens?
Almost since we started, I actually don't remember, probably 2007, 2008.
All right, that probably covers Siemens stuff. Shall we move to Oregon?
Sure.
That was really good. Battleships are cool.
Yes, that was.
Um,
I don't have my bad horse Winnie down.
your what?
Oh,
Oh.
you've never seen Doctor Horrible?
No.
Oh, everybody has to see Doctor Horrible.
Should I put it on my must-see list?
You
I have to
you
send back
you
my,
should.
my Netflix today
It's
since I
it's
watched the
on
movie last night.
it's on Netflix streaming. It's three 15-minute episodes.
This was the Doogie Howser, right?
Yes.
John,
Neil Patrick Harris.
Patrick Harris.
Dr. Horrible.
Yes. You have to watch it. It's 45 minutes of your time that is well worth it.
Okay. What and iHardware platforms have you worked with?
I guess I could say most of them. Everything from their standalone DAC cards that are installed in a computer to the PXI chassis, MXI, PCI extension cards, USB DAC, compact Rio. Uh, there are a few that I haven't worked with, but for the most part, if NI makes it, I've probably done it.
And then what industries have you worked in with NI, LiveView stuff?
Industries have been much like DMC as a whole across the board. Automotive, I believe we've done some medical, uh, also just manufacturing in general, uh, test and measurement, research and development. I've done work at uh, several national laboratories, from natural gas industry uh, to actually Fermilab. Actually, I didn't do Fermilab. One of our other guys did a Fermilab project.
And here, I think you were gonna talk about the 4W Dyno project.
Right. For one of the national labs, we did a uh, dynamometer project. They test advanced powertrain vehicles. This is your hydrogen engines, your gas electric hybrids, your plug-in hybrids, your electric vehicles, your advanced diesel. Basically, if it's not a what they call an ICE engine, internal combustion engine, it's the type of thing these guys are looking at. They're trying to find what really are the best practices, what's the best equipment, what's going to meet people's needs in the future. And as part of this, they have a dynamometer. And a dynamometer is basically it's a rolling road. It's a way of simulating driving down the street, and um, it can change the force. Pretend you're going uphill, downhill. It can simulate the amount of wind that is passing across the vehicle, so that you can get as close of a representation of what would happen if you were driving on, say, a flat road with no wind as possible. And part of this is they need to collect a lot of data. A traditional dynamometer, they might be looking at one or two things. These guys are looking at the vehicle as a whole. They're collecting the temperature of the engine. They're collecting the force output from the transmission, maybe with a sensor they've had mounted in the transmission. And they're doing all of this while trying to, of course, replicate these conditions exactly. They built a hot room where they can go up to 90 some odd degrees to simulate a hot summer day, and down to below freezing, I forget exactly how far, to simulate cold weather. And so our task on this was to develop a system that integrates all of these various pieces together and collects the data, combines it into one piece, and spits out a result within a couple minutes after the end of the test that says, this is how the car performed. And it lets them see that the results were good, bad, if there was something surprising, so they can say, let's look at this a little bit more, without having to go away and spend a few hours looking at data and then coming back and saying, yeah, we need to look at that again. So it gives them really real-time results, which is something that's not necessarily as common in the laboratory world as you might want.
And why would somebody want to choose DMC for that?
Oh, we have several. Do you know how many, as an aside, do you know how many LabVIEW architects we have?
I don't know what the latest number is.
We've got me, Darren, Jesse, right?
And Danny there?
I don't think Danny's.
No.
I'll just go with 3.
Okay.
Um, we have at least 3 LabVIEW architects right now, with a couple more that are looking at upgrading their developer status to architect status in the near future. We have several LabVIEW developers. Those who aren't yet experienced enough to be LabVIEW developers have or are getting their LabVIEW associate developers certificates within the next month. So we have a wide range of certified staff members. We have a long history of successful projects that have solved problems in really interesting, elegant, amazing, and most importantly, robust ways. And on top of all of that, we have our state machine architecture. We call it the Sea Monster. It's a cute name we came up with a few years ago. that doesn't matter. What does matter is that this platform can be adapted to almost any application and allow us to develop a full, robust architecture with a I'm blanking here. It allows us to develop a full, robust architecture with a most cost-effective, fastest way. So what we wind up with is the ability to do rapid development with also code that is going to be maintainable long-term.
And then, did you want to say anything about SSI end of line?
SSI end of line, that one was just a tester on the end of a manufacturing system. This could be any of a number of projects we've done where there is a machine that assembles a part, does something, and at the end, this part had a lot of requirements that it had to meet to be a good item because it was going into an automotive application. On top of that, it's an automotive application dealing with steering. And so anything that's going to be requiring that kind of importance in a vehicle needs to be tested so that we know that it's good. And so the end result of this test was that we could look at all of the inputs and outputs of the electronics on this device and determine this is good, this is bad, and accept or reject it into the system and log all of that into a database. So now the engineers had the ability to see what their yield rate was, what the results of what the results of the passed and failed tests were, so they can go back and correct manufacturing defects and keep their yields in a level that keeps them profitable and meeting their production rate.
And how long have you been working in LabVIEW stuff?
I've been working on LabVIEW stuff since before I joined DMC, so that's been since 1996.
Awesome. Cool. Well, I think that's all.
All right, great.
Isn't so bad.
It was horrible.
Now you're all done. Okay.
Do we get a nice big loud action?
You just got a microphone. Okay, you ready? You speeding? Yeah. Speeding.
Aaron.
Hi guys.
So what Siemens hardware platforms have you worked on?
I've worked primarily with Siemens Step 7 and the WinAC platforms on some of the projects I've worked on.
Are you two lab back? Are you two lab back there? Hey. Scold her if she does it again. Okay. What industries have you worked on in Siemens?
Probably the coolest project I've worked on that's been a Siemens project has been in the high-tech manufacturing field. Should I just start that over? That whole thing over again. So probably the coolest project I've worked on, at least with a Siemens core, has been for a company that is in the high-tech manufacturing business. Basically, they have large industrial furnaces they use to melt down a raw material and run it through a recipe process that makes it into a nice single crystal stock that can be used in precision electronics and basically various high-tech applications. So the project, at least the PLC side of the project, involved using a WinAC, Siemens WinAC platform, which is a software PLC, as opposed to an actual discrete hardware device. This is actually a kind of a simulation of a PLC that runs on a Windows, basically a Windows box. And the way we deployed this for this particular project was on was considered called a microbox. It's an industrialized PC that runs, it's got a dual core processor in it, one that runs the real-time Siemens WinAC platform. The other side runs a stock Windows XP installation that hosts all of our kind of application client-specific software. So what's cool about that is you can do all of your prototype testing and deployment all on one PC, and there's a shared memory block that you can use for easy communications. What we ended up doing was somewhat non-traditional. There's a kind of a whole software stack. It starts with the WinAC platform itself. There are some DLLs that were written that transfer some of that data in the form of tags to our application software that does the business logic of these big furnaces. So it implements the recipe process, does data transfer back to the PLC itself to control outputs and read inputs. And it also communicates that data forward, kind of up the stack through Windows Communication Foundation, WCF server, to a human-machine interface, an HMI that's written in .NET, C#. And that, again, is a tag-based transfer. So you get that information back. It can be displayed on the screen, and the screen can be customized. What's also really cool about that is multiple HMI clients can connect to the WCF server. So there's one server publishing all of the information, and as many clients as we feel necessary to read that information. Pretty cool project. I think the real strength there is that they can take the software we've written, and they can take this common platform and they can apply that to as many different of their products as they want using a kind of a common foundation. They can write just a few, basically take that standard library code and mold it to their application's purpose. So it's very flexible. Another thing that was really cool during the development, at least from a PLC standpoint, is we could simulate the entire PLC program on our PC. Since it's software PLC, you can actually spoof out the inputs, outputs, and not even require any hardware to be connected to debug the entire the program logic. So it was a very streamlined process versus having to go to the hardware, basically test your code for the first time on the actual hardware, which can be challenging and sometimes it's very expensive to take the machines offline in order to run these non-productive tests.
Is that it? Did you just do all of it in one?
I don't know.
I think you did. In one breath. Yeah, I mean, why would somebody want to choose DMC for a project like this?
Well, DMC's very experienced with Siemens platforms. In fact, we were very experienced with a huge number of PLC platforms, but Siemens has been our bread and butter for many years, and we've got a lot of experience doing projects in many different industries with a ton of Siemens platforms. So the other thing that's really cool is our engineers are trained in software, but we are also kind of based in electrical and mechanical foundations. So we, as opposed to someone who just writes software, we have a better chance of really understanding the application and being able to write efficient code for that application.
That's it. Yeah, that does it. Thanks, Ryan.
Do you guys do a thing with the board that at the end? God. All right.
Hi, Boris. How many years have you been working with Siemens?
Probably over 10 years, 11, 12 years.
And what Siemens hardware platforms have you worked with?
It's a wide range of platform. I've been working with your S5, which is very old platform. I think it's out of production last 5 years or so. And all modern PLCs like a 400 series, VNCC flexible, pretty much everything. Okay, I will. All right, totally. again, pretty much everything, starting with your food and beverage industry and the heavy machinery, machine builders, um, again, everything, automotive.
And why would somebody who's looking for Siemens development choose DMC?
Well, for multiple reasons, I guess. First, because Siemens, if you compare automation platforms to like vehicles, so you get the bicycles, you get the cars, and you get the Siemens, which is it's pretty much like a James Bond car. So it could do everything. It could fly, it could shoot missiles, lasers, wherever you can imagine. But the problem is that it comes with some few extra buttons, like a James Bond car, and it's not as easy as ride a bicycle. So here you need someone like DMC to kind of guide you through and show you how to use it and show you how to program it. Um, that's the primary reason to hire DMC for Siemens. Is just have someone who has a lot of experience in that platform because it is a bit complex.
What are some of your most unique or challenging projects you've worked on that are a good example?
I couldn't think about anything particular. Well, again, something what I like is the flexibility of the platform. So when you have customer who has the initial requirements, but somewhere along the way they are bump it up to the extreme, and because of the flexibility of the platform, we can still accommodate their new requirements. Um, that's what it's challenging, yes, but it's doable because of the flexibility of the platform. Yes, totally. You can't do that on some other platforms.
What about, let's say, Wrigley, anything?
Rigor related.
Since
Um,
you've worked on everything.
yeah, that's a problem. Okay. I couldn't think about any specific super awesome projects when we've done something. Well, everything at some extent super awesome. So, well, okay. We got a project and the customer spec a particular PLC platform that we would like to use, and they are along the way they decide that they want something like much more powerful and they need more speed, they need more memory and everything. And the challenge was actually it wasn't a challenge. It was a benefit of the platform. We just replace the hardware and keep the old software pretty much unchangeable. It was the same software running on a totally different hardware platform, and it was a total success because of unification of the Siemens platforms.
Other projects? What's the most awesome project
Well,
you've done here?
with the other there are good examples. Probably GD Solar. You have someone talking about that. Most of the PLC is kind of open program environments and open architecture, so you could see a logic what's going on in a PLC. You can figure it out. You can reverse engineer it. Siemens has amazing option to make it so encrypted and so hacker proof that you're. Don't take me wrong. You can still probably steal it and reverse engineer it, but it'll take so much effort comparing to everything else that it would be not practical to do that. It would be easier to rewrite your logic from scratch than to reverse engineer something what you've done on a specific Siemens platform. What I'm talking about the VNAC platform. VNAC with external logic could be extremely secure.
So that was for GT.
That's what GT doing. Yeah, it'll take years to reverse engineer it. What do you do? what would you do there?
Can you describe the project like big
And a lot of platforms you can upload it. You can basically
can you
copy it
describe
over.
what the project was?
The project was your sapphire furnaces. It's used to grow artificial sapphires, and sapphires used in the well, jewelry, yes, but mostly for semiconductor industry, LEDs and other semiconductors. Um, the process they use is quite unique, and they don't want to share details of their process with anybody else. And they realize that their hardware and software was copied because it was protected but not very well protected. So they went to Siemens route and implement very secure, very high encryption, high protection level using a Siemens platform.
I think that's it.
Awesome. Carlos.
I think start over. I've worked in the automation industry. Start over, excuse me. I've worked in the automobile industry. I've worked in the battery testing industry. I've worked as well as in the food industry, and then also in vision inspection, which has a lot of different applications.
And what different platforms have you used?
Mainly LabVIEW. Been using LabVIEW 2009 through 2012. And both Windows-based systems, RT systems, a little bit of FPGA as well.
And then projects that are unique, interesting applications.
I think one project that was unique and that makes DMC. I guess. Hold on one second. Let me think about how I'm going to phrase this from what we talked about before. I'm not going to say the name. One particular unique project that comes to mind is a project we did with a company that specializes in automotive suspension. In this project, we did not necessarily head up a software suite development. In this case, they were in a position where they were down a developer. They were kind of in an emergency situation, so they gave DMC a call, and we were, instead of developing a suite for them, we came on board and worked with their team. It was a very collaborative process where we came on board and learned how their internal processes worked, learned their applications, their product, and worked with them to achieve their very timeline tight specific project goal. So that worked out very well. It was rather than having one specific fixed bid project, we offered support over multiple months, and as additional projects arose and they had increased need for developers, we were able to allocate our time and come on board and help them out. So in that case, DMC, rather than offering standalone software development, we can also offer team support, adding another person to add resources for a particular project's timeline or budget-related items, I guess. Okay. Yeah, I think that's.
That was a really good example.
Okay, thank you. Yes.
Hey, John.
Hey, Jess.
What Siemens hardware platforms have you worked with?
I've worked with a whole bunch of them. I've worked with the S7 300 line, which is one of their larger ones. I've worked with the S7 1200 line, their newer line, WinCC HMIs, WinCC Flex HMIs. Worked with the motion control hardware that they have, like Simotion D425s, using the Simotion Scout software. So a pretty broad base of their automation technologies.
And what industries have you worked in with Siemens?
Let's see, I've worked in food and beverage industry, pharmaceutical industry, printing, automotive, medical. I'm sure there are others, but they blend together.
How many countries or which countries have you?
I've traveled all over for Siemens customers. I've been to China, I've been to Germany, Poland, Canada, Turkey, and that's all I can think of off the top of my head, but there may be others.
Let's see. How long have you been working with Siemens?
Ever since I started at DMC, so about 4.5 years ago.
Why would somebody want to choose DMC for Siemens projects?
Well, the thing about DMC and Siemens is we have more solution partners than anyone else in the country, maybe the world. Besides Siemens themselves, maybe they have more. But as far as solution partners, we're one of the largest, and with that in mind, we've worked on more projects than probably all of the others, and just have more experience in general. We also have very close relationships with Siemens themselves, both within like their support teams as well as their internal development teams that created the software and hardware that we're using. We have a very tight relationship with. So that's probably why.
Specific projects that have been unique or challenging?
One of the more unique projects that I've done with Siemens was a high-speed packaging machine that had to package a piece of candy, basically, with a primary layer of packaging. So it had to fold aluminum over this candy at something like 3,000 pieces per minute. And at that rate, you can't see what's going on at all. It looks more like a fluid than a piece of candy. And you have to be extremely detailed oriented when something is going that fast. So it was a lot of fun to work through all of the challenges that came with going at such a high speed. And it was neat to see how it worked and how they got it running.
What was your solution?
The solution was a servo-based machine that it was a little bit of a retrofit on a previous design that they had that was VFD and mechanical cam based. We took out a lot of the mechanical cams and put in servo drives, and that allowed us to be more flexible with the motion, change motion on the fly instead of being restricted by a mechanical gear or cam. And then put more options in the hands of the operator. If they needed to tweak something to make it go a little faster, they had the ability to from the screen. So it's nice.
Should I look?
So how long have you been working with LabVIEW?
I've been working with LabVIEW pretty much since I started here at DMC, so at least 3.5 years or so. I'm working with it pretty consistently.
What platforms have you worked with?
I guess a good variety. I've done a lot of development on just Windows PC applications and the LabVIEW development environment, and then also some work on real-time applications as well as some custom FPGA development. And also working with quite a few different hardware platforms, development with sort of traditional M series and X series DAC modules, USB DAC devices, as well as some higher end applications with the PXI platform. All kinds of modules for that, relay multiplexing modules, digital multimeters, all kinds of DAC hardware, custom source sync power supplies, and then also again with the cRIO platform for real-time and FPGA applications. guess the biggest one that I've spent the most time working in would be applications related to the automotive industry. A lot of battery testing applications directly geared towards development of batteries for large automotive manufacturers. And then in addition to that, some other applications in the medical field, medical devices and diagnostic systems, as well as several applications that are kind of related to specialty powertrain, so some custom dynamometer systems, as well as some test applications for endurance testing of some specialty bicycle, high-end bicycle components. So those would be some of the big ones.
Why should somebody consider DMC for their LabVIEW-related projects?
I guess a whole host of reasons. One would be the level of experience and background that we have. We have at least 4 certified architects here on staff, as well as a large number of certified LabVIEW developers and associate developers. So we just have a huge background and level of experience in it. We have seen and worked with pretty much the whole host of hardware and software platforms that National Instruments offers. So we will have the ability to bring a lot of different options for different solution architectures to the stage and decide which one is the best fit. And then I guess another topic or another factor that has a big benefit is our use of kind of reusable code and modular architectures. So we have this state machine architecture that is a common centralized building block that allows us to create modular code that has similar structures across the organization so that different developers can easily transfer on and work with the code and be familiar with the overall architecture off the bat. And it just is a very flexible architecture that molds itself well to a variety of both control and user interface side applications and functions that are very common for the majority of the applications we work with.
What, I guess, start with the CMH project. What was unique or challenging or interesting LabVIEW-wise for that application?
Sure. So, I mean, I guess the project itself was pretty unique and novel in that it was a kind of leading edge system that was something very new that was being implemented in a real world hospital environment for the first time. So this project involved a thermoregulatory chamber that was geared towards use for diagnosing conditions in patients where they had problems with metabolic regulation, regulating body heat. And the purpose of the chamber was to control their body temperature very precisely and carefully so that they would have normal metabolic regulation responses like sweating, and then monitor them very closely during this process to observe abnormalities and sweat patterns and things that would help the clinicians and doctors diagnose and draw conclusions about these conditions in the patient. And this was an application that was, in a strategy for diagnosing these conditions that was really new and had actually been developed at the Mayo Clinic and as sort of some cutting edge research, and was being implemented in a hospital environment for, as far as we know, the first time, as DMC worked with a major children's hospital here in Chicago to set up this thermoregulatory chamber. So the application itself was just really new and kind of a neat thing to be working on. And then it was also very, very interesting in that even though it was a fairly well-defined application, not extremely complex, but it employed a very diverse set of the tools, both hardware and software, that National Instruments and LabVIEW has to offer. So we had a Creo controller with an FPGA, and we use this FPGA for some of the really low-level critical safety functions, because obviously with this we have to be very careful to never heat the patient's body temperature up higher than safe levels. So we had custom FPGA code to do those lower-level safety functions. We had a real-time controller running custom control software to do PID temperature control necessary to perform this thermoregulatory chamber temperature control. And then we had a PC Windows side application that provided a nice user interface for the doctors to both set up the test that they wanted to run and view the real-time results. So we were using, both the CREAR platform with FPGA along with both FPGA coding real-time and the PC side LabVIEW development environment. So pretty diverse implementation of LabVIEW tools for the application. So that was another interesting aspect of it.
Have you seen it at the hospital?
I have seen it as it was being installed, but not the final implementation as it was up and running. Darren finished most of that up. Yeah.
I toured there before COVID. We were installing it then. I was like, where's that? Where's it?
Yeah.
And then anything you can say about SRAM?
Yep. So for SRAM, we worked with. So SRAM is a company that develops. Their core business is developing really high-end bicycle components for very serious cyclists. But one of their bigger projects recently has been they're participating in the design of the World Bike, which is a low-cost, high reliability bicycle designed for use in developing areas where just having a bicycle can be the foundation of basically having the ability to run a business by transporting goods from rural areas into a village or into markets, and where just the bicycle itself is very reliable can be a very important tool. And so for this, it obviously has to be extremely reliable, and things like the normal cable-based shifting and braking mechanisms that are on most of the bikes we're used to have way too many potential, too high of a potential for failure, so that won't work. They were developing a specialized, fully enclosed clutch that would do shifting and braking entirely within a clutch hub on the rear wheel that allowed these bicycles to basically eliminate most of the most common failure modes. And our role in this was to develop a test system that used a servo motor to kind of perform endurance testing of this hub that put it through a bunch of simulated pedaling profiles.
Right, same thing.
Yes. So one of the growing and developing industries that DMC has become pretty heavily involved with over at least the last several years now is the battery industry, and we have been involved in developing many test applications both on the research and development side as well as the actual production and end-of-line testing side for really large-scale lithium-ion battery packs that are being developed for use in vehicles such as electric cars that are now on market. So we've worked with both on the research side with institutions like Argonne National Labs here in Chicago, as well as battery developers who are direct suppliers to automotive manufacturers. So we've done testing at both the battery pack level and evaluating kind of the power and performance characteristics of these battery packs, as well as test applications for battery management systems, which are the kind of intelligence in a battery pack that tests whether the battery pack is operating in a safe condition and if temperature conditions are safe throughout the battery pack and things like that. And so we've done some hardware in the loop style test applications for battery management systems. And so, yep. That's it, yep.
I think that's it. That should be good.
Okay.
Thanks,
All right. Thanks.
Jesse. Darren,
Yes.
how long have you been working with LabVIEW?
I personally have been working with LabVIEW since 1996. Started using it in school, and then I was doing pretty serious LabVIEW development ever since. So, for a while, yeah.
DMC worked with LabVIEW in?
LabVIEW can kind of cross a lot of boundaries in terms of industry and in terms of essentially phases of product development. So my start was really in research, kind of pure research, and then into technology development. And from technology development, it goes into products, and there's product development testing and bringing products to market. And then often the same tools you write in that environment will go into manufacturing and quality testing. So, so LabVIEW can kind of cross into all of those areas of work. In terms of industries, that can be in pure research, as I mentioned. It could be transportation. We've done a lot of work with high-tech components for automobiles, so transportation is a big one. Medical devices is another one, where you go from concept to prototype in terms of integrated test fixtures, and then bringing that up into an actual product itself, and then into manufacturing. So medical devices is another one. I guess there's a variety. Food and beverage is another one we've done some with. So compliance testing is another big one. We work with a few of the big labs around here. One is Underwriters Laboratories, where we do test fixtures to test things like smoke alarms to make sure that they are alarming when they should, or carbon monoxide detectors, or various other safety-related features in these products. Yeah.
And what platforms have you worked on?
Platforms for specifically for National Instruments. The platforms, I would say, 12 years ago, everything was on Windows or Macintosh, but real-time is probably what we're doing the most of now. So this runs on a real-time application or a real-time operating system. It's much more robust. And then there's also FPGA, which is a field programmable gate array, and you can actually put LabVIEW programming down onto the FPGA, which is super fast, and it's very robust. It'll run forever, essentially, or run a very long time. So we see a lot more of those in manufacturing and even in some product development. Vision applications will often have custom FPGA and real-time code. So there's a device called a EVS, Embedded Vision System from NI, that we've had some great success with. It's a pretty cool product. So yeah, real-time FPGA and Windows.
Why would somebody who's looking for LabVIEW development choose DMC?
Somebody looking for LabVIEW development would choose DMC because one, we're really good at it. We enjoy it, and we've seen a lot of kind of crazy things that we've pulled off around here. We also are very heavily certified. Our experience is reflected in our certifications. We have 5 certified architects, which is the highest possible level, and it's still a fairly coveted level to reach in the LabVIEW world. We also have a handful of certified developers, and then a few more that are associate developers that are moving their way up. We also have 2 certified professional LabVIEW instructors as of this year. Myself and Patrick are both instructors, so we're looking to start teaching some classes here, which demonstrates our ability to get things done and know what we're talking about. We are part of the NI Alliance membership. We've been a partner of NI's since 1996. We've been able to host some events with them. There's the NI Week conference every year that we go to that we're a part of. There's a local technical symposiums. We also have hosted the most recent LabVIEW users group here at our office with about 40 people coming here, and we build a demo for them and are able to display what we're doing. So we have a pretty close relationship with NI in terms of knowing what solutions are out there, what products are coming out, what products are out there now, what the best tool for the job is. Many times there's many different ways to approach a project, and we can evaluate them, and we know basically if we're making a decision down one path, we're doing it very intelligently. So we know what we're doing is the bottom line. We've done on most of these types of projects before.
So there's 5 architects, you said?
Yes.
Okay. Somebody said 3, somebody said 4.
Well, I guess Yeah, we will have 5 this month.
Okay.
So I guess we have 4 right now,
So
but
five
5 are in.
five is what it looks
Yeah,
like.
5 is in
Is he
progress.
taking it now?
Yeah, Patrick is.
Oh, okay. Oh, he's
Yeah.
not already?
What's that?
He's not one already?
No, I mean he operates at that level, but he hasn't taken it yet. So yeah,
Um,
we'll have 5 by the end of 5, and yeah,
by the time this video is done.
it's in progress. Yes.
And then any special, I mean, I think you hit all the credential stuff. Anything, project-wise that you want to hit on? Jesse talked about Children's Memorial and about SRAM and, CPI. Dan mentioned Tenneco. Leanne talked about Argonne, dynamometer. I think that was all we
The
had.
Argon battery test system is probably the biggest implementation we have.
Yeah,
I also was going to talk about the hospital project. If you think it's worth iterating again, I don't know.
yeah, I think so, just to get, see if there's anything new that comes up. Okay, so yeah, I guess, do you wanna talk about hospital first? Anything that was unique or especially challenging, interesting about that project or DMC's application?
Okay, what did Jesse talk about?
He was talking, I mean, he just kind of did an overview of what it was and
Okay.
the precision involved.
Okay. So the project for the hospital is unique in that it's taking a relatively simple engineering application and now applying it to humans, essentially. So it's controlling the body temperature of a human being. In this case, this was designed and implemented for the new Children's Hospital in Chicago. And as you can imagine, it's got to work. It's got to be safe, and it's got to be effective. So it was a really fun project to work on. We got to interact very closely with the clinicians at the hospital and actually get some volunteers up on the test bed and run some tests. And it had some pretty strict requirements for operation. From an engineering standpoint, it was a pretty simple problem. Translating that into a device in a hospital setting was some interesting considerations that we had to take into account. But ended up being a fantastic project and kind of a different perspective for a company like us. The other project is the Argonne National Labs. We have kind of a facility-wide implementation there where they can run close to 300 simultaneous tests that are testing batteries for electric vehicles. They're doing essentially benchmark testing for development of technologies for electric vehicles and batteries and fuel cells. So it's a huge implementation. There's tests that are running around the clock for 6 months or a year at a time. They're collecting massive amounts of information and doing a lot of data processing on it. So it's a widely distributed system it's very powerful. I think it's set up in 3 or 4 different labs within one building out there, and they're like I said, they're just churning around the clock, running lots of tests and generating data on some cutting-edge technologies.
Is there anything vision related we want to overview?
There's some really cool vision stuff. I don't know if we can talk about any of it. I don't know how much I can talk about with those. And yeah.
Okay.
Hi, Tim.
Hey,
How many years have you been working with Siemens?
I think I've been working with Siemens for about 10 years now. It's been quite a while. Our relationship with Siemens has grown really strong over those 10 years. We've formed really tight relationships with the local Siemens people, as well as we've got a lot of really key contacts throughout the Siemens global organization. Why does that benefit our customers? When there's a problem or some special thing that needs to happen, we pretty much know the right people to talk to throughout the organization. It could be a local person, it could be someone in Germany, or someone in one of the offices throughout the U.S.
What platforms have you worked with, or has DMC worked with?
We've worked on just about every Siemens automation platform that you can think of. So starting with a really low level S7200 PLCs, which were replaced with the S7-1200, up through the what I'll call the industry workhorse, which is the S7-300 line, S7-400, which is seen in a lot of larger applications. We've done projects for airports. We've done work on battleships. Any kind of really mission-critical application would typically use S7-400. And then we've done a lot of motion control applications with their Siemens product line. Siemens is a really powerful motion control platform. It can handle, up to hundreds of axes, which it's really good for both small, simple projects all the way up to huge production lines. We've had really good success with that platform. It's extremely powerful. I've yet to see a motion control project that we couldn't do with Siemens. And then on the HMI side of things, we've worked on their WinCC Flex platform, which is now called WinCC Advanced or WinCC Professional. And that is used in all throughout industry for industrial touch panel control of just about anything you can imagine. We've used their WinCC product line, which is typically used in larger industry applications. So, factory control where you're looking at your entire process, where you need a visualization for your whole plant or your whole assembly line, your whole production line. Now I'm drawing a blank. You've got the list, right?
Okay. And what industries has GMC worked on at Siemens?
Okay, industries. DMC does not have a specific industry niche that we work in. We really work in a lot of different industries. And the common thing that we do in all those industries is programming. So it ranges everything from pharmaceutical, food and beverage, automotive, chemical applications, transportation, converting, processing, material processing, and then a lot of specialized machinery, specialized manufacturing. Let me think about this for a minute. The power industry, we've done work in the power industry. Should I start over when I make a mistake, or are you just going to edit the hell out of this? Okay, because I can try again if you want me to. Okay. So, what was it? We were talking about different industries.
What industries has GMC worked on at Siemens?
Do you actually have the list, like that we?
Industries?
Yeah.
No, I don't have a list of
Okay.
industries.
Because we had that page, and we had that page on our website that showed all of our industries.
I was gonna say industry windows has technologies. What do I have a bunch of on here? Can we talk about the airport?
Sure.
I think that was on our list. And then I'm trying to look at the people who weren't here to talk about their stuff.
Cesar was going to talk about the airport.
Well, yeah, he's not around. And then you're talking about flying cutoff for Ken. He's not around. Yeah, I guess for that, we want to talk about what certifications DMC has for Siemens.
Yeah, we can just make it generic and talk about the solution partner
Yes,
program.
partner.
Okay.
So can you explain what the solution partner program is? How DMC is involved?
Yeah. So DMC we're really proud to be a member of the Siemens Solution Partner Program, which is basically it's a list of solution providers that Siemens, it's a short list actually of solution providers that Siemens would recommend to a customer of theirs when they need programming or commissioning services. In order to get on that list, you have to take actually it's a very difficult test. It consists of a practical exam, which includes PLC and HMI debugging and programming, and then a written exam. And it's a hard test. I've taken it. It was not easy to pass. which is good. It means that they really want their solution providers to be top notch. DMC currently has the highest number of certified S7 Siemens programmers of any country in the US, so we're pretty proud of that. What else can I say about that? Let me look at my notes really fast.
And I guess any other benefit to the customer aside just they're super certified and recommended?
Say that again?
Any other like benefit to the customer for being a solution partner?
Oh, okay. Yeah, sure. So the benefit that a customer would get by working with a certified Siemens solution partner is, first of all, they know that the engineers they're working with have been certified. They've been trained on the equipment and the software. They've taken a test, they've passed it, and moreover, they have worked with Siemens before. They know the right people at Siemens to call when there's a problem. So they're not just individually technically capable of solving these problems, but being part of the solution partner network means that you know the right people at Siemens to contact when you need extra help. That's a really big benefit to our customers. Siemens is a huge organization and they've got tons of resources. So if we can pull from those resources strategically, knowing the right people to call at the right time, that really benefits our customer. It gets things done more quickly, helps us solve more complicated problems faster.
And then what did you want to say about the relationship with distributors?
Okay. Let me collect my thoughts for a second.
Just like a CD sales, like that kind of relationship?
Yeah, like Steiner.
Oh, Steiner, yeah.
Steiner's probably the big one locally. We good? Okay.
Okay. So what does that relationship look like? What does it end up meaning for the customer?
DMC has a pretty tight relationship with the local Siemens sales force and the local Siemens distributors. And we can, working with distributors, we form a unique partnership in that the distributors, they're in the business of selling the hardware and supporting the hardware. And DMC is really good at designing the software solution and doing the implementation. So together, when we go into a customer and DMC is providing the software, the distributor is providing the hardware, we can provide this complete solution where both parties are doing what they do best. And in the end, the customer gets a much better product and has extensive support.
I guess just any specific unique, interesting projects you want to highlight?
Did you want me to talk about the airport a little bit?
Yeah, since Cesar's right here, I think that's probably a good one. Who else? I mean, a couple people mentioned Wrigley vaguely. If you want to just briefly overview that, or
I'm not.
flag cutoff project, if that's unique in general.
I can talk about the airport. I didn't work on it, so I won't. It'll just be kind of a top-level overview.
So what was the Dulles Airport project like?
Oh, we did a really interesting project for Dulles Airport where they were installing their new train system to shuttle passengers around the airport. Our part of the project was to program all of the PLCs and their communication with the train system, and all of the control system for. Sorry, that's not what we did. Let me start over.
I didn't notice.
Okay. That was mostly what we did. That was mostly correct, but I'm going to start over.
Okay, so what
Okay.
did we do for Dallas Airport?
DMC worked on a really interesting project for the Dulles Airport. It was for their new train system that they used to shuttle passengers between gates. And our part of the project was the fire protection safety system. So if there's a fire in the tunnel, these fans would kick in, and they would blow air into the right places, and they would take heat and air away from the passengers to keep them safe. It was a mission critical application. It used Siemens' most powerful processor, their S7400H, which is it's a redundant processor, meaning there's two. So if one fails, another one would kick in. And we also used their WinCC SCADA system, which also was redundant. So they had double redundancy with the system, and it was critical that if there's any issue in any of these tunnels, that the system take over and provide safe evacuation for the passengers. It was a fun project to work on because it was very challenging, getting all of the communications working correctly, and making sure that it was always a safe system was absolutely critical. We worked on that project for the better part of a year, and it was a great success.
No accidents yet.
No, not yet. I think it'll be all right.
Anything else?
I don't know that we have full permission to talk about that. I think we do, but I don't know 100% that
Do we
we're.
wanna just,
I don't know. I need to talk to Cesar.
okay, do you wanna just, shoot the beginning of that again and just say like a major airport?
I can. Yeah, how can I just boil it down to something super simple?
And then we could edit together.
We just worked on a.
technical part.
Yeah, I just don't know if we have permission to talk about that. I didn't talk to Siemens about it,
Okay.
so I could just dumb it down.
Okay.
Had you talked to him about it?
No,
Okay.
we have a case study on, right?
And we say Dulles?
I don't know if we say Dallas in the case study.
Okay. I'll just say that we did a project for a major airport, for the train system for a major airport, fire protection, a 7400.
Yeah.
I don't have to get into a lot of the
I guess
details.
Yeah, like the Siemens point of view.
Sure.
Okay.
Are you rolling? Okay. We did a really interesting project, a Siemens project, using their most powerful processor, their S7400. It was their H processor, which is a redundant processor. There's two, and it has a fail safe. So if one has a problem, the other one will kick in. This project was for a major airport, and it was for their new tunnel system that they were putting in to transfer passengers between gates. Our part of the project was to make sure that these fans would kick in if there was any kind of a fire, and it would pull air into the right places to give the passengers the oxygen they needed, and it would pull hot air and fire away from them by turning on a series of fans. It was a very mission critical application. There was human safety in the mix, so it was a really big deal, and we had to make sure that at every point that safety was the utmost importance in programming this project. The Siemens solution worked out really well. They had exactly the support that we needed to accomplish the task. Their HMI system that is used to control everything was also redundant, so if one of the PCs had an issue, another one would kick in. So at all times, the system was fully safe.
Siemens?
I could talk about the automotive stuff that we've done. Those are kind of fun.
Okay, cool.
Probably one of my favorite projects.
What was that for?
It was for Android Industries.
Oh, okay.
It's going back a while, but it was pretty neat.
Do you have to be vague on that?
I can be vague enough. Is that loud? What was it? Hmm.
Do your kids do that?
They haven't learned that one yet. I don't know why.
Don't bring them here.
No.
Okay, so you're gonna talk about what was interesting about the Android Industries project?
Yeah, one of my favorite projects that we've done with Siemens was for the automotive industry, where we were asked to redesign a production line in such a way that it was super flexible. In the automotive world, when a car is being produced, they make a lot of changes very rapidly, especially if it's a new model. So our system had to be able to rapidly adapt to these customer changes. Historically, the way that they would do that would be by having a programmer just basically attached to the line at all times, making these changes on the fly as needed. So what we did is we came in and we created a really powerful system that consisted of a bunch of tool sets that the customer could then select how the system worked and the order of operations that things were performed in. And they could make all of the necessary changes without a programmer needed at all. That project was neat because it was a really sophisticated system, and when we were done with it, the customer almost never called, which is a good sign. It means that they were able to just take the system and run with it, and all the changes that they needed to make, they could make them themselves without a programmer. That made me feel really good. It made me feel like we did what we set out to do. We made a system that could stand on its own and could stand the test of time without having us constantly have to maintain it. That type of system is the type of project that I really enjoy getting involved with. And we try to make every project that flexible.
Anything else? Missing anything? Distributors, local, corporate, relationships.
I can talk about a solution partner council.
Is that different from the user advisory?
Yeah, it's a little bit different.
Okay, sure. Council sounds so dramatic.
Yeah, there's not a whole lot to talk about here, but I think it's literally like one sentence that I would say. It's basically just.
What's the council?
Are you good? Yeah. So in addition to being Siemens Solution Partners, we're actually on the Solution Partner Council, which is really just a group of solution partners that meet and discuss how they work with Siemens. We share best practices. We'll actually go visit other solution partners and talk about how they've used Siemens technology successfully. We'll share business practices and really learn from one another. It's much more of a collaborative type of a situation than competitive, which is what you would normally expect when working with other companies that are kind of doing the same thing that you are. But we take a totally different approach to that, and the Siemens Solution Partner Council helps facilitate that.
Do you want to say anything generic about Wrigley? I don't know if you can really encapsulate everything we've done for them into, or if there's something unique instance that we want to highlight for them.
I'm just so afraid to. I could say we do work for,
confectionery
you know,
or food and beverage or?
we have a really large company that work with a confectionery company that uses Siemens almost exclusively, and we've done work in all their factory. I mean,
I don't
trying to
know, like,
figure out how to make that interesting without saying anything.
Any, like, I don't know, yeah. Anything that they've done really
They've made us take everything off our website that has to do with Wrigley, so that's why I'm afraid to.
okay. Anything to do with like starting factory from scratch and programming the whole thing? No, can't say that.
Why don't I just talk a little bit about why I like Siemens products?
Sure.
Okay.
Wow.
So DMC, we're a platform independent company. We'll work on just about any platform. If it involves software and it's in a factory or a laboratory, we probably work on it. But I really like working with Siemens products because they're so powerful. It's a platform that is, I'll call it a programmer's delight. We can always accomplish the task at hand with a Siemens solution. I can't say that for every single platform. We've done some really challenging projects, and whenever we really need to push the envelope, do something that's kind of outside the box, we really go to Siemens. I don't know if I should have said. I may need to tone that down a little
Okay.
because I don't want to. It's too much of a commercial for Siemens.
Okay, it's a commercial for DMC Siemens.
Let me try this again. Well, I was just thinking because we work with other. I don't want some Alan
Yeah.
Bradley person seeing that and being like. Okay, I'll tone it down a little.
Are we gonna do an Alan Bradley commercial?
Probably. Why not? Okay.
So what do you like about working at Siemens?
I really like working on Siemens projects for a lot of reasons. One is that they have a huge portfolio of products, so it seems like no matter what the challenge is, they've always got a product or multiple products to solve that problem. And then once you've selected the product, it's extremely powerful. They're PLC platforms. You can use them for programming very simple applications, but we've also done a lot of really advanced Okay.
You can use it for programming simple.
You can use it for programming both really simple systems or extremely complex systems. We've got projects going on right now that involve their S7-1200, which is a really simple PLC controlling, a small machine. But at the same time, we've done some really advanced communication processing projects where we've written entire suites of Ethernet communication libraries using their S7-300 product line. It seems like no matter what, we can always find a solution with within the Siemens product line. Is that a little better? Okay.
Am I missing anything? Does that cover all your notes?